Hello students, today we shall start with MCQs on ray optics, that is reflection of light through spherical mirrors. Before we start with this, let's try to recall some of the relations that we have learnt. From the laws of reflection, we have seen that the angle of incidence will be always equal to the angle of reflection. Next, we have learnt the relation between the radius of curvature of a given spherical mirror and its focal length, which is given by r is equal to 2f. Then we learned the relation between the object distance, image distance and the focal length of a mirror, which is given by the mirror formula, and the relation is 1 over f will be equal to 1 over u plus 1 over v, where f is its focal length, u is the object distance and v is its image distance. Then we learnt the magnification produced by a mirror, which is the ratio of the height of the image or size of the image to height or size of the object, and in terms of image distance and object distance, it is given by minus v over u. So in addition to these relations, it also becomes convenient to know the relation between magnification produced, focal length of the given mirror and its object distance. To get the relation between these quantities, let us consider the mirror formula, which is given by 1 over f will be equal to 1 over u plus 1 over v. To get this relation, just multiply this equation throughout with object distance. Thereby we get the relation as u over f to be equal to, it is 1 plus 1 u over v. So we require the relation between, that is, we require the ratio of v by u. Thereby I can write u by v to be equal to u minus f, u by f minus 1, or we can write u over v to be equal to u minus f by f. But or from this we can write the ratio of v by u to be equal to f by u minus f. So with this as a reference, we can write magnification produced, which is given by minus v over u. Thereby the relation comes out to be, it is f by f minus u. So this will be the relation between magnification produced by a mirror, its focal length and object distance. Same way, you can just get the relation between magnification produced, focal length of the given mirror and image distance, for which we need to multiply the mirror formula with the image distance, follow the same steps, and it can be shown that the magnification produced in terms of the focal length and image distance comes out to be equal to, it is f minus v by f. So these are some of the relations which will be helpful. And keep in mind that these relations will be, you can make use only for your solving your MCQs. This should not be used for your board exams. So with this relations as the reference, let us start with the MCQs on your CET classwork. So the first question goes like this. A small object is placed 10 centimeters in front of a plane mirror. So let us consider that you are given with a plane mirror and you have an object placed, say, at a distance of 10 centimeters from a plane mirror. So if you stand behind the object, so the position of the observer here is behind the object and at a distance of 30 centimeters from the mirror. So the observer is at a distance of 30 centimeters from the mirror. So and he looks at its image, that is image of the object. So the distance focused for your eye. So that means to say you need to find the distance of the image from the observer. So in case of a plane mirror, we have seen that the image will be formed behind the mirror and it will be at a distance equal to the distance at which the object is placed in front of the mirror. So that means to say the image of the object will be formed at a distance of 10 centimeters behind the mirror. So as a result of which the distance of the image as observed by an observer will be equal to, it is 30 centimeters plus 10 centimeters, which will be equal to 40 centimeters. So the distance of the image from the observer here will be 40 centimeters. That is your option C. Next, the second question goes like this. So you have a concave mirror of focal length f which produces an image n times the size of the object. That means the magnification in this case is given to be n. So if the image is given to be real, so for the image to be real, by convention we can say that the magnification produced for a real image will be negative. So magnification produced will be negative for a real image by convention. So then you need to know the distance of the object from the mirror. So that means to say you need to know the relation between the magnification and focal length and also the object distance, for which let us consider the relation between magnification, focal length and object distance given by m will be equal to f by f minus u. So here the magnification is given to be n, and as the image is given to be a real image, magnification will be negative. So for a concave mirror, by convention the focal length will be negative. By convention focal length will be negative. So you need to find the object distance. The quantities which has to be calculated, you are not supposed to apply the conventions. So as a result, keep it as minus u. So let's try to rewrite this relation. Just cross multiply. So we'll get it as nf plus nu, which will be equal to minus f. Or we require the object distance. So nu can be written to be equal to minus nf minus n. Or this can be written as minus n plus 1 into f. So this will be equal to n into u. So but we require the object distance. So object distance can be written to be equal to minus n plus 1 into f divided by n. So this will be the relation for the object distance if the image produced is a real image and if it is n times the size of the object and focal length f. So as a result, your option D will be valid. So n plus 1 into f by f. And the negative sign is by convention. That is, if the object is a real object, then your object distance will be negative. Next, the third question goes like this. So you are given with a real image of half the size is obtained. So again, just similar to the previous example. So you have the magnification produced here, which is equal to half, and as it is given to be a real image, so for real image magnification is negative. So the radius of curvature is given to be 40 centimeter. Once the radius is 40 centimeter, you can write its focal length, which is equal to r by 2, that will be equal to 20 centimeters. So you need to find out the distance of the object and its image. So make use of the same relation, that magnification in terms of focal length and object distance given by f by f minus u. So magnification here is given to be half, and as it is a real image, it is minus. So focal length, as the given mirror is a concave mirror, focal length will be negative and it is 20 centimeter. So 20 centimeter. Object distance you are supposed to calculate, so don't apply the sign convention. So on rearranging this equation, that is on going for the simplification, you can show that the object distance comes out to be equal to 60 centimeters, and negative sign indicates that the object is a real object, so thereby it is at a distance of 60 centimeters. So object distance will be 60 centimeters. Same way, you also require the distance of the image. So as we have learned that the magnification will be given by minus V by U. So magnification here is given to be minus 1 by 2. Image distance you are supposed to calculate, and object distance is 60 centimeter. So therefore you will get image distance to be equal to minus 30 centimeter. So the image will be formed at a distance of 30 centimeters. So object distance will be 60 centimeter and image distance will be 30 centimeter. So your second option is valid. Next, the fourth question goes like this. So you have a concave mirror having the focal length 15 centimeter forms an image having twice the linear dimension of the object. So again, the magnification is given to be 2, but here the image is given to be virtual. So if the image is virtual, by convention magnification will be positive. So again you need to find the position of the object, make use of the same relation that m will be equal to f by f minus u. So magnification here is 2, and as it is virtual image, it is positive. And again here a concave mirror is given whose focal length is 15 centimeter. For a concave mirror, by convention the focal length is negative, so it is minus 15. Object distance you are supposed to calculate, so don't apply the conventions for your object distance. So on cross multiplying and on simplification, you can show that the object distance comes out to be equal to minus 7.5 centimeter. Again, negative sign indicates that it is a real object. So our first option is valid. Next, the fifth question goes like this. An object is 20 centimeter away from a concave mirror of focal length 15 centimeter. If the object moves with a speed of 5 meter per second along the axis, that is along the principal axis, then you need to find out the speed with which the image moves. So for which, let us consider, so you have your mirror formula given by 1 over u plus 1 over v to be equal to 1 over f. So we need to find the speed with which the image moves as and when the object is moving with certain speed. So as a result, let us differentiate this equation with respect to the time t. So on differentiating 1 over u, so on differentiating you will get as 1 over u square minus 1 over u square into du by dt minus 1 over v square into dv by dt, because as and when the position of the object changes, the position of the image also changes. Whereas here focal length for a given mirror is constant. As a result, differentiating a constant will give you a value equal to 0. Now in this equation, the quantity like du by dt gives you the rate at which the object is changing its position. That means du by dt will give you the speed of the object or the speed with which the object is moving. Similarly, dv by dt will give you speed with which the image will be moving, which is supposed to be calculated. So on rewriting this relation, you can write the speed with which the image moves to be equal to minus v square by u square into du by dt. So here this negative sign indicates that the image will be moving in a direction opposite to the direction in which the object will be moving. So here we know the distance at which the object is placed, which is given to be 20 centimeter. So to find out the speed with which the image moves, we need to know the image distance, for which, so just let us make use of the mirror formula, that is 1 over u plus 1 over v to be equal to 1 over f. So here object is placed at a distance of 20 centimeter, and as it is a real object, it is by convention negative. So image distance you are supposed to calculate. So don't apply the convention for unknown quantities. So focal length of the given mirror is 15 centimeter, and as it is a concave mirror, by convention it is negative. So on solving this equation, you can show that the image distance comes out to be equal to minus 60 centimeter. So simplification part, you just try it out and find. So as we know the image distance now, let us try to find out the speed with which the image moves as the speed with which the object is moving is given. So it is dv by dt, which will be equal to minus v, which will be 60. So even you can take the sign 60, and object distance is 20 into the speed with which the object is moving is given to be 5 meter per second. So just simplify this and find out. You will see that this comes out to be equal to 45 meter per second with negative sign. So negative sign, as I have told you, it indicates that the image will be moving in a direction opposite to the direction in which the object is moving. So as a result, here it is fourth option. So the next question goes like this. As the position of the object reflected from a concave mirror is varied, the position of the image also varies. So you need to find out which of these graphs will be valid for a graph of v versus u. So here you are changing the object distance from say 0 to infinity. So let us consider when your object distance is equal to 0. It means the object will be placed at the pole of the mirror itself. So if the object is placed at the pole of the mirror, the image will also be formed at the pole of the mirror. So as a result of which, so you can see here, when the object is at the pole, that is 0, object distance is 0, the image distance will also be equal to 0. So as a result, you can easily eliminate your second option. So whereas third and fourth object distance and image distances will be 0. Then let us consider when object is placed at the focus. So when the object is placed at the focus, the image will be formed at infinite distance. So whatever dotted lines shown here will be the distance, like object distance, which is equal to say your focal length. So when the object is placed at the focus, the image will be at infinity. So in either direction you can take it as a reference. So from these two values, you can see that when the object is at focus, the image distance has to be infinity. But if you take the second case, so this will be already eliminated. So in this case, you can see that it is infinity. So this is not valid again. And if you look at the relation between your object distance, image distance and focal length, that is your mirror formula, you can see that it is not a linear variation. So as a result, your third option is not possible. So with this as the reference, the only possible graph here is the first graph that you are going to have it. So the variation of v versus u will be just somewhat similar to the first graph that you are going to have it. Next, let us go to the next question. So the question goes like this. So it is given that you have a concave mirror and the real image of the object is formed. So you need to plot a graph of 1 over v as a function of 1 over u. So as we require the relation, that is a variation of 1 over v versus 1 over u, let us make use of your mirror formula, which is given by 1 over f to be equal to 1 over u plus 1 over v. So in this case, we require the graph between 1 over v and 1 over u. So just rewrite it. So it is 1 over v, which will be equal to, it is 1 over f minus 1 over u. Now in this case, So as it is given that a real image is formed. So if the image formed is real, then your image distance will be negative. Same way, as it is a concave mirror that is given, again the focal length will be negative and your object distance by convention will be positive. Sorry, by convention it will be negative for a real object. So therefore you can rewrite this relation to be equal to, it is 1 over V, which will be equal to, it is 1 over U minus 1 over F. Sorry, 1 minute, it is minus, so you will get this as 1 over V to be equal to minus 1 over U plus 1 over F. So this is just similar to, suppose if you rewrite this, if we require the graph of 1 over V along the y direction, so that is y will be equal to, and along the x-axis you have 1 over U as the quantity, so we can rewrite this as m into x plus the 1 over f, which is a constant, so let us write it as c. So that means this is similar to an equation of the straight line. So as a result, the graph of 1 over V as a function of 1 over U should be a straight line graph. But here you are getting that the value of m, which is nothing but the slope of the straight line, which is equal to minus 1. So it means you are getting a straight line with a negative slope and its y-intercept being plus 1 over f. So with this as a reference, you can see that. So if you look at your first graph, it will be a straight line graph with negative slope and y-intercept which is positive. So this will be your y-intercept and slope here will be equal to negative and it is equal to minus 1. So as a result, the possible graph here is your first graph. Next, coming on to the next question. So he says that you have a man of height or length equal to h requires a mirror to see his own complete image. So what should be the length or the minimum length of the mirror that is required? So for which, so let us consider that. So you have a person whose length is given to be h. So this will be the height of the person. So let us consider this to be the head of the person and this should be the feet of the person. So let us consider you have the position of the eye of a person to be at somewhere here. So let us consider that you have a plane mirror which is placed in front of a person. So you have a plane mirror in front of a person. So here your work is to find out what is the minimum length or the least length of the mirror so that the person will be able to observe his complete image. So let us consider the required length, minimum length of the mirror is y, which you are supposed to calculate. So just by making use of, so the light coming from head, that is light falling on the head, which falls at one end of the mirror. After reflection, it has to be focused to the eye so that you can see the image. So if you draw the normal here, so this will become your angle of incidence and your angle of reflection. So by the laws of reflection, angle of incidence and angle of reflection will be the same. So just to go with some mathematical treatment. So let us consider the distance of the head and eye to be equal to, say, something like x. Then the distance from the eye to the feet will be equal to, it is h minus x, as the total height or length is taken to be h. So here, as you have the angles to be same, you can say that this part will be equal to x by 2 and this part will be equal to x by 2. So same way, so the light that is falling on the feet has to get reflected through the mirror, and it has to be focused onto the eye so that you can see the feet of the observer. So again, just by following the laws of reflection, these angles will be same. As a result, these distances will be equal, which will be equal to, it is h minus x by 2 again. So we require this particular distance. So as a result, we can write here that y, which is the size of the mirror, will be equal to, it is x by 2 plus h minus x by 2. So it is x by 2 plus h minus x by 2. So on rewriting this, you can rewrite it as x by 2 plus h by 2 minus x by 2 plus x by 2 minus x by 2. It is h by 2. So the minimum length of a plane mirror that is required in order to observe the full image of an object will be equal to half the size of the object. So you can recall this result directly and you can write it. So the next question goes like this. An object 5 centimeter tall, that is height of the object is given to be 5 centimeter, and it is placed 1 meter from a concave mirror. So the distance at which the object is placed is given to be equal to 1 meter, and as your options are given in centimeter, let us convert meter to centimeter, that is 100 centimeter. And the radius of curvature of the given mirror is 20 centimeter. As radius is 20 centimeter, its focal length comes out to be equal to 10 centimeter. So you need to find out the size of the image. So to find out the size of the image, as the object distance is given and focal length is given, let us find out the magnification produced. So magnification produced here is given in terms of focal length and object distance as f divided by f minus u. So therefore you can write magnification to be equal to focal length is 10 centimeter, and as it is a concave mirror given, by convention the focal length of a concave mirror is negative, and object distance is given to be 100 centimeter, and by convention it is a real object, so it will be equal to minus 100 centimeter. So on simplifying this, this will be minus 10 and this will be 90, that will be equal to minus 1 by 9. So magnification produced here is 1 by 9. But as the height of the object is given and we require the height or size of the image, so by definition magnification is given by height of the image to height of the object. So height of the magnification here is minus 1 by 9. Height of the image is required and height of the object is given to be 5 centimeter, and by convention we consider that the object is placed above the principal axis, so by convention it is positive, that is size of the object is positive. So therefore height of the image comes out to be equal to minus 5 by 9. So on simplifying this, you will get height of the image to be equal to around 0.555 centimeters. So as a result, your third option is valid here. Next, coming on to the next question. The question goes like this. The focal length of a concave mirror is given to be the 50 centimeters where an object be placed. That means to say you need to find the object distance so that its image is 2 times and inverted is 4 times. So focal length is given to be equal to 50 centimeter. Object distance has to be calculated. Its image 2 times, that means magnification is given, which is equal to 2 times, and it is inverted image. So once the image is given to be an inverted image, definitely it has to be a real image. So once the image is real, by convention magnification will be negative. So again make use of the same relation, that is relation between magnification, focal length and object distance. So magnification here is minus 2, focal length here is 50 centimeter, and for a concave mirror it is negative. So concave mirror, it is negative. Object distance you are supposed to find out. As a result, don't apply the convention. So thereby, if you need to calculate the object distance, simplify this. So you can show that object distance comes out to be equal to minus 75 centimeter. So our first option will be valid. Next. The question goes like this. You have a convex mirror which is used to form an image of an object. Then which of the following statement is wrong? So we have seen, in case of a convex mirror, the image formed will be always a virtual image. So once it is a virtual image, it has to be an erect image, and it will be formed behind the mirror. Behind the mirror, and it will be always between the pole and the focus. So just check out this result, recall this result. With this you will be able to account for this. So the image lies between pole and focus. That is a correct statement. The image is diminished in size. So again, in case of a convex mirror, again the image will be always a diminished image that you are going to get it. So it is correct. The image is erect. Erect image is obtained. The image is real. So in case of a convex mirror, there is no possibility of getting the image to be real irrespective of the position of the object. So as a result, the wrong statement here is your fourth statement. So the next question. The image formed by a convex mirror of focal length 30 cm. So focal length is given to be 30 cm, and it is 1/4 or quarter the size of the object. That is, magnification is given to be 1/4. The distance of the object. So your object distance has to be calculated. So let us make use of the relation between magnification, focal length, and object distance. So here, as it is a convex mirror given, so the focal length will be positive by convention. And in case of a convex mirror, you will see that the image formed will be always a virtual image. So as the image formed is virtual, by convention the magnification will be positive. So thereby you have the magnification produced to be equal to 1/4. The focal length is given to be 30 cm, and object distance you are supposed to calculate. So just rearrange this equation, solve it. You will see that the object distance you will get it to be equal to minus 90 cm. Again, minus negative sign indicates that it's a real object which is placed at a distance of 90 centimeters in front of a convex mirror. So our second option is valid. Next, let us go to the next question, where the question goes like this. So you have a virtual image which is 3 times the size of the object. So magnification here is given to be 3, and as it is a virtual image, by convention the magnification will be positive. So with a concave mirror of radius of curvature is given to be 36. So therefore focal length will be equal to 18 centimeters. The distance of the object. So make use of magnification in terms of object distance and focal length. So here magnification is given to be 3. Focal length, as it is a concave mirror, it will be negative, and it is 18. So 18, and object distance you are supposed to calculate. So on simplifying this relation, you will see that your object distance comes out to be equal to minus 12 centimeter. Again, negative sign indicates that it's a real object placed at a distance of 12 centimeters in front of the mirror. So your second option is valid. Coming on to your 14th question. So it says that you have a point object which is placed at a distance of 10 centimeters. So your object distance is given to be 10 centimeter, and its real image is formed at a distance of 20 centimeters. So image distance is given to be 20 centimeter. So from a concave mirror, so if the object is moved, that means you are changing the position of the object by 0.1 centimeter towards the mirror. So let us imagine the change in the position of the object to be du. Du here is given to be 0.1 centimeter. Then what will be the distance through which the image of the object will be shifted? So for this, let us consider your mirror formula, which is 1 over u plus 1 over v will be equal to 1 over f. So differentiate this equation with respect to u. So on differentiating this equation with respect to u, you can just rewrite them and you can arrive at the required relation. So let us see that. So if you differentiate this equation with respect to u, so first term will be minus 1 over u square plus it is minus 1 over v square into dv by du, which will be equal to, as focal length of a mirror is constant, differentiating a constant will give you a result like equal to 0. Now rearrange this equation. So you can write that 1 over v square into dv by du to be equal to minus 1 over u square. So we require the change in the position of the image, which can be written to be equal to minus v square by u square, or dv will be equal to, it is minus v square by u square into du. So just substitute the required values. So change in the position of the image will be equal to, it is minus v is given to be 20, and as it is a real image, by convention it will be negative, and object is placed at a distance of 10 centimeters. So again a real object, so 10 centimeter, and it is moved by 0.1 centimeter. So on simplifying this equation, you can see that the change in the position comes out to be equal to minus 0.4 centimeter. So here negative sign indicates that the image will be moving in a direction opposite to the direction in which the object will be moving. So here he says that the object is moved towards. So if the object is moving towards the mirror, the image has to be moving away from the mirror. So it will be moving by 0.4 centimeter and it is away from the mirror. So as a result, your first option will be valid. So this will be the questions on your CET classwork. So the CET NEET classwork problems we shall see in the next part. Thank you, students.